Sorry, just realised I was making a video getting into the music there. Sorry, the Batman music. Okay, mechanics video. Mechanics. What are we talking about? Newton's law of restitution. So we're talking about collisions again, but further this time. And E, what is this constant E? I know it's a bit annoying to use the same letter for something different because we know E is 2.712, blah, 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 which is, you know, the transcendental number E. We also know, for those of you who have done any work with parabolas or hyperbolas and stuff, that E is stands for eccentricity of the curve. But in this context, E stands for Newton's law of restitution. Now, what is E? What does it mean? What we're talking about is comparing the materials of the particles colliding or the balls colliding. So before, with our work, we didn't consider that at all. We just looked at their starting velocities, their end velocities. But what happens if we didn't know some of that information? Well, if we knew something about the materials, then we could find that information out. It's very similar to on a slope when you have friction as being mu r. Well, what is this mu, this coefficient of friction? That's this arbitrary measure of the roughness of that slope against the particle in question. So it's the relationship actually between the particle and the slope surface. Just like E, it's the relationship between this material and this material. Think about it, if I make a ball of blue tack versus a marble ball, like a snooker ball, when those two things collide, the blue tack is going to kind of slump, isn't it? It's going to kind of take take a lot of that absorption of that energy, and a lot of kinetic energy will therefore be lost. Whereas if I had two marble balls together, they would kind of rebound and bounce off each other quite well, do you see? So the formula for E is the absolute difference in speed of separation over the absolute difference in speed of approach. Now, you're not really going to know what that means until we start using examples, but please just remember it's separation over approach, never the other way around. Separation over approach. Things could go really wrong if you don't remember that. Now, E ranges between 0 and 1, and we say that if E is 0, we have a perfectly inelastic relationship there, i.e., maximum amount of kinetic energy is being lost. It means if two balls collide, they just won't move anywhere. They'll just stop. Okay? Whereas if E equals 1, we have a perfectly elastic relationship between the two materials, which means essentially the speed at which they collide, when they rebound, no kinetic energy overall will be lost. Okay? This means all kinetic energy is lost, and this one would mean nothing has been lost. There's a perfectly elastic relationship. Now, the law only holds if we're talking about two balls on a on a smooth surface. Okay, it has to be smooth. You won't have any problems when there's friction involved. The law also holds only when there's direct impact. So if we're talking about a smooth surface, those two balls have to be the same size, but not necessarily the same density, right? I.e., the center of those are in line with each other. Because if they weren't in line with each other, right? Let's say one of them was bouncing. The center of those balls, once they collide, you'll see that this ball would probably go off this way, and this one will go off this way. You'd have what's called an oblique impact. We only are dealing with direct impacts here, where the result could be this ball could go this way, and this ball could also continue going this way, or they could rebound off each other, or they could both switch direction completely. Okay, well, hard to imagine a situation where that would happen, but how else could you have a direct impact if we don't have a horizontal floor involved? Because think about it, if we had a horizontal floor involved and the balls were different sizes, then the centers again would not be in line and you'd have an oblique impact. But if you had two balls of different sizes, the only way that they could have a direct impact is if they were floating in space. that they weren't rolling along a surface, because that way their centers could be horizontal to each other, okay, or in line with each other relative to our directions. Okay, again, like I said, you're only really going to understand this until we do an example. So let's go through it. We should be used to setup here. So I've got two small spheres, P and Q. So I'm very particular about how we do mechanics. Every teacher thinks, you know, their way is the best way. And I'm the same. It's not necessarily the best way, but the way that it always works for us. And you need to follow the system that I'm presenting to you. Because if you're consistent with me, you will never get this wrong. The minute you start being a bit of a smart ass about it, things start breaking down and it won't work, right? It's very particular mechanics. Now it says before the impact, sphere P is moving with speed 11. So sphere P, notice the direction arrows I'm putting there. So important, the direction arrows. And it says Q is moving the opposite direction with 7 meters per second. After the impact, P's direction of motion has reversed. So we said it was going right, so now it's going left, and that's VP. Please set this up exactly how I'm setting this up. And it's now moving with speed 6. And VQ is moving with 3. Again, its direction also reversed. So we want to try and find this E here. Notice I'm always putting the impulse in straight away because I might need that later. Anytime I know there's a collision, there's going to be an impulse associated with it. So here I've got Newton's law of restitution. I'm going to state a positive direction. All mechanics rests on everything to be being relative to each other. So if I'm saying positives to the right, everything is relative to the right. So E is difference in speed of separation. Now this is absolute difference. There should never be any negatives in here. Everything is relative to the right. So even though this speed is bigger, it is going in the different direction to my positive direction. So think about it. If you want absolute difference of something, it has to be fastest thing minus slowest thing in the direction that I've defined as positive. So the fastest thing going to the right is 3 minus, because it's difference, the next thing, which is 6, but that is in the opposite direction, so it's going to be minus 6. Think about it. It's like having minus 6 on a number line, and there's 3, and there's the origin. What's the absolute difference between the two numbers? Well, you can see it's 9. Okay? But think about it that way. Fastest thing in the positive direction, subtract the next thing. Over separate difference in speed of approach. So again, fastest thing going right is this one, that's 11, take away. This thing, which is 7, but it's going in the opposite direction to what I've said it is positive. So therefore, it gives me 9 over 18. So E is a half. Okay, example 1. Example 2, which is up here. Let's bring this down. Okay, a bit more involved now. So, same setup. A, B, ball. E is between them. They're colliding. See, immediately I'm setting this up in exactly the same way. 200 G, that means 200 grams, but we always work in kilograms. And it says that A is going with 5 meters per second. Good. B, 0.4, moving in the opposite direction with 4. Given that the coefficient of restitution is a half, find the velocities A and B. Now this is the thing. How do I know if after these two things collide, A is going to go left or right? And the same with B. I don't know. I can have a kind of educated guess, but it's still a guess, and the maths is going to tell me what the right answer is. But the most important thing is the diagram tells me everything. The diagram is stating right from the start, I'm making assumptions. My assumption is that A is going to go right and B is going to go right. If I get a positive answer for A, then I must be correct in my assumption. If I get a negative answer for A, then I must be wrong. It must be left, not right. Okay? keep on to that fact. If you understand that theory, you'll be able to do every question on this topic. So we're going to start with Newton's law of restitution. We're going to go right. E is a half, and that's the difference in speed of separation. So think about this. My separations are VB and VA. Which one must be faster in the direction to the right? It must be VB, because remember, this is after they've collided. If VA is faster than VB, then that means they're going to hit, and then they're just going to keep hitting, keep hitting, keep hitting. Or VA is literally going to go through VB, isn't it? Because VA is faster. A is moving faster than B, if I assume that. Which isn't possible. It can't go through something, can it? So VB must be faster. It must move away from A once they collide. And on the bottom then, fastest going to the right is 5, subtract, B is going 4, but in the opposite direction. So can you see, if I times up by the 9, you'll see that I'm going to do the algebra very quickly, because I know you can do algebra. So notice I've got an expression for VB. Could have made VA the subject, doesn't matter. I've got an expression for VB, but I've got two unknowns here. I've got VB and I've got VA, but I've only got one equation. Where do I get the other equation from? That's right. I can hear you screaming into your headset. Comp, exactly. The conservation of momentum principle, which we know very well now, is m1 times initial velocity 1 plus m2 initial velocity 2 equals m1 v1 plus m2 v2. Momentum is conserved. That's what this means. Everything is to the right. It's so important that we're putting directions here. This is what I'm talking about when students take shortcuts. If you don't state the direction, you're going to get all of your signs and stuff in a muddle. You must be consistent. So we're going to state everything to the right. So I've got mass, speed plus mass, but VB is going to the, UB, sorry, is going to the left. So that must be -4, because my positive is to the right. Equals mass, 0.2, times VA. And VA is going to the right, I've assumed. Which means I assume it's going to the right in comp. Plus 0.4 VB, as I've assumed VB is going right. So here I have 1, subtract 1.6, so that's -0.6 is 0.2 VA plus 0.4 VB. I now need to sub in my VB. So I get -0.6 is 0.2 VA plus 0.4 times 9/2 plus 0.4 times VA. So if I rearrange for VA, again, I do the algebra quickly, because you should be stopping the tape and doing the algebra for yourself. Do not be passive watching me, because I could make a mistake, right? So I get VA as -4. I'm going to talk about what that means in a second. VB then is 9/2 from here plus VA. So this must be 0.5. Okay, so let's talk about what this means. Our conclusions. Conclusions. So the speed of VA, it's 4. Speed's always positive, isn't it? But now I need to understand what that minus means. I assumed VA was going to the right from my diagram. If I get a negative answer then, my assumption must be wrong. It must be going left. But the examiner doesn't know what left or right means. You need to say relative to its starting direction. I assumed it was going to go right, which means the direction would be unchanged. But I'm wrong. This is a negative answer, so it must be 4 meters per second in the opposite direction. So direction reversed. Okay? Likewise, speed of VB is 0.5. I assumed VB was going right. I was correct because it is a positive value. So the direction of B has reversed or changed, okay? So you must understand what the positive and negative means because it's all relative to the diagram. The diagram means everything for mechanics. Okay, last one, a bit harder this time. So, two small spheres, should be getting used to this. PQ, there we go, there's E. They've got an impulse straight away and just immediately put that down. Masses, okay, moving towards each other in opposite directions. So UP as 3U meters per second, UQ must be 2U, right? The coefficient of restitution is E. It doesn't tell me anything about their final velocities. So again, I'm going to assume that they move to the right. That's my assumption. So it says first, show the speed of Q is U over 7, 15E plus 1. Notice it says speed, which means if you get a negative for speed, your assumptions must be wrong. Okay, so it's what you'll see is it's always the same. Like they look complicated, but even successive ones, it's always comp and Newton's law of restitution. It's always the same. E equals, right. So again, which one must be faster to the right? It must be VQ, mustn't it? Because otherwise VP would pass through VQ. Which is going fastest to the right? 3U. Minus. The other one is going to the left. So that's subtract 2U. So that's 5U on the bottom. So I get 5UE. Is VQ take VP. I'm looking for the speed of Q. So again, you're good at maths. We're going to optimize how we do maths. So it makes sense for me to make VP the subject because I'm trying to find VQ and I'm going to need to sub that in to comp. So comp to the right. So mass, velocity, mass, velocity, negative because it's going to the left, equals mass VP, mass VQ because I assumed VQ is going to the right. Notice that the M's will cancel. Whoops, that was a U, but it doesn't matter. So 3 times 3U is 9. U, subtract 8U, so I'm left with U. 3VP plus 4VQ. I'm going to sub in my VP. So U is 3 lots of VQ, take 15 UE, plus 4 VQ. Again, you should be pausing the tape, solving this yourself, because I'm doing the algebra quickly. So I'm going to move the 15 UE over. So I get 7 VQ is U plus 15 UE. Divide by the 7 to get rid of that, and take out a factor of U over 7. And I get what they asked me for. 7. Cool. Done. Part A done. Now, part B. This is the thing. This is the theory. Direction of motion. Given the direction of motion of P is unchanged, find the range of possible values of E. What do I do with that? My diagram tells me everything. I assumed VP was going to the right. I assumed P's motion was unchanged. Therefore, my answer for VP must be positive. VP must be bigger than 0 if the direction of motion is unchanged, because I assumed the direction of motion was unchanged. If I was wrong, if it says given the direction of motion of P was changed, then my VP must be less than 0. It must be negative, right? Because I assumed right is positive. So first, I need to find VP, because at the moment I've got VQ and I don't have VP. So again, the algebra, I'm going to do quickly. So U over 7 plus 15 UE over 7, we just found that, minus 5 UE. 5 UE is 35 over 7. So that means I'm left with U over 7 plus, minus 20 UE over 7. Okay? I'm going to move this up. VP then, if I take out the u over 7, is 1 minus 20e. But I'm saying this must be bigger than 0. You have to understand why that's bigger than 0. If you don't understand, you need to ask me. You need to talk to me. It's fundamental to your theory that you understand why this is bigger than 0. Because I assumed it was already unchanged. Okay, if it was changed, and I assumed it was unchanged, this would be less than 0. Okay, now divide by u over 7. 0 divided by u over 7 remains 0. So get 1 minus 20 bigger than that. So move over the 1, divide by the minus 20, and you get e is less than 1 over 20. But you know that e can't be less than 0. So e must be between 0 and 1 over 20. Okay? Part C, given the magnitude of the impulse is this. So I'm straight into I equals m v take u, my impulse momentum principle. So imp, find the value of e. So where should we do it? Because remember, to use imp, we need to isolate a particle. From my diagram, I might as well go for q, because I know I need to do it in the direction of impulse, and there's more things going to the right than there are to the left. So from my diagram, I'm going to go to the right at q, because the impulse is to the right. So impulse is ATMU over 9. It doesn't matter if I do it at P or Q, that's going to be the same. The mass is 4m, so 4m. V is going to the right, which matches the direction of impulse, so that's positive. So that's VQ, u over 7, plus 15 UE over 7. I just worked that out here. Minus our value of UQ. But UQ is going to the left. So this is minus 2U, which becomes plus. Notice straight away the M's cancel. Notice straight away the U's cancel. Okay, so I'm left with 80 over 9 is 4 over 7. Again, I'm doing the algebra fast. 60 E over 7 plus 8. So if I rearrange, I should get E equals, use your calculators at the same time as me. 4 over 7. 1 over 27. Perfect. And there's E. Okay, that's the end of this video. Like I say, you're working independently here. You must work through the examples. Pause the video, do the examples again if you need to. But you can't just watch it. You have to get involved and try it for yourself for you to really understand what's going on.